Okay, so strength of materials or mechanics of deformable bodies. Start with stress and strain. So stress is the internal force per unit area set up at various sections of the body. So stress sigma is equal to F over A, where F is the force or load acting on the body, and A is the cross-sectional area of the body. So normal stress sigma is the force per unit of normal area. Shear stress tau is the force per unit of shear or parallel area. Strain is the deformation per unit length when a system of forces or loads acts on a body. Strain is equal to epsilon or delta L over L. Or delta L is equal to EL. So actually, pwede mo ang tanggalin yung L dito sa isa. Isang buo yan. Delta L, change in length of the body, and L is the original length of the body. Yeah? Huwag mong cancelin yung L. Okay? Dilation is the sum of the strains in the three coordinate system. Hooke's law, modulus of elasticity, modulus of rigidity, or shear modulus. Hooke's law is a simple mathematical statement of the relationship between the elastic stress and strain. Stress is proportional to strain. For normal stress, modulus of elasticity, E is equal to sigma over epsilon. And for shear stress, modulus of rigidity is equal to G is equal to tau over theta. Stress over strain. So the relationship of modulus of elasticity and modulus of rigidity is G is equal to E over 1 over 2 times 1 plus mu. Mu is the Poisson's ratio. Okay, so example number 29. What modulus of elasticity and tension is required to obtain a unit deformation of 0.00105 meter per meter from a load producing a unit tensile stress of 44,000 psi? Solution, simple lang. E is equal to stress over strain is 44,000 divided by 0.00105 or 41.905 times 10 exponent 6 psi. So the answer is letter D. Sample number 30. A wire length 2.5 meters has a percentage strain of 0.012%. When loaded with tensile force. Determine the extension of the wire. So delta epsilon is equal to delta over L. So yan ang formula. So percentage strain ang given mo, kaya 0.012 divided by 100. So equals to delta over 2.5. So delta is 3 times 10 exponent negative 4 meters, or multiply mo ng 1,000, magiging 0.3 mm. This is letter B. Next, working stress and factor of safety. Working stress is a stress lower than maximum or ultimate stress at which failure of the material takes place, also called design stress, safe, or allowable stress. Okay, anong pagkaiba ng design stress sa working? So, design stress based doon sa properties ng material, and working stress based doon sa actual load. Diba, yung may giving ka ng diameter, may giving kang area, so divide mo yun doon sa load, that is the working stress. Pero pag wala kang dimension, so ano ka sa properties ng material or sa stress niya, ultimate stress, so that is called design stress. So factor of safety is the ratio of maximum stress to the working stress. So factor of safety is maximum stress divided by the working or design stress. So for ductile material, that is mild steels, the factor of safety is the yield point stress divided by the working or design stress. For brittle material, that is cast iron, factor of safety is ultimate stress divided by working or design stress. Notes on design stress and working stress. Ito nga. So, ito yung design stress is stress used in determining the size of a member, allowable or less. Working stress is stress actually occurring under no operating conditions. Yan ang pagkaiba niya na. Okay. So, tensile stress in strain. So, tensile stress based on figure is sigma T is F over A. Tensile strain, epsilon T is equal to delta L over L. Okay. Sa machine design review, babalikan din natin to. So, example number 31. A steel tie rod on bridge must be made to withstand a pull of 5,000 pounds. Find the diameter of the rod assuming a factor of safety of 5 and ultimate stress of 64,000 pounds per square inch. Solution, sigma u over n is equal to 4f over pi d squared. So 64,000 divided by 5 is 4 times 5,000 over pi d squared. So d is equal to 0.7052. Asan dyan? Letter B. Example number 32. The diameter of a brass rod is 6 mm. So what force will stretch it by 0.2% of its length? So brass is 9 times 10 exponent 10 Pascal. So delta is FL over AE. So this is na 0.002 L is equal to FL over pi over 4 times 0.006 yung 6 mm squared times 9 times 10 exponent 10. So cancel mo yung L, makukuha mo yung F na 5,089.4. So letter A. Compressive and stress and strain. So same lang siya sa tension. Sigma C is equal to F over A. EC is equal to delta L over L. Sample number 33. A round steel bar 12 inches long is to withstand a dead load of 40,000 pounds in compression. So the rod must not shorten more than 0.004 inch and have a factor of safety of at least 10. Assume the ultimate strength of the material to be 110,000 psi and modulus of elasticity to be 15,500,000 yan 1,000 psi. Okay, determine the diameter of the rod. So delta is equal to FL over AE. So 0.004 is 40,000 times 12 over pi over 4 d squared times 15,500,000. Okay, walang problema sa units, inches, PSI ito. So D is equal to 3.14 inch. So letter C. Next, shear stress and strain. Shear stress is the stress induced when a body is subjected to two equal and opposite forces acting tangentially across the resisting section, intending the body to shear up. Shear stress is the tangential force divided by the resisting force. So tau is equal to F over A. Shear strain is measured by angular deformation accompanying the shear stress. That is the angle, shear strain. So example number 34. 6 inches diameter rivet undergoes a shear force of 1,750 pounds. Find the average shear stress and the rivet. So that's this F over A lang. So 1,750 divided by pi over 4, 6 squared is 61.9 psi. Sample number 35. If the ultimate strength of a steel plate is 42,000 pounds per square inch, what force is necessary to punch a 0.75 inch diameter hole in a 0.625 inch thick plate? So yan yung puncher. The force is sigma u times pi times dt. That is the ultimate strength times yung shear area, di ba? Pi dt. Yan ang shear area mo. So that is 42,000 times pi times 0.75 times 0.625. So yung ultimate strength yan is, ano yan, yung binanggit sa problem. So yan na yung ultimate niya sa shear. Is 0.625, 61,850 pounds. Shear dapat to. Okay, kasi shear lang yan. So, 61,850 pounds. Okay? Or more. Yeah. Pag nilagay mo yung or more, ito lang minimum. Lagi tinatanong is yung minimum. So, this is 61,850 pounds or more. Kala mabutas mo siya. Pag less than ka, so hindi mo mabubutas. So, that's letter C. Next, bearing stress. Bearing stress is a localized compressive stress at the surface of contact between two members of a machine apart that are relatively at rest. Application is riveted joints, scattered joints, knuckle joints, etc. So for riveted joints, the bearing stress is sigma B or sigma C is F over DTM. Yung projected, hindi yung may pi, hindi siya referential. So D, diameter of rivet, T, thickness of plate. So DT is the projected area of the rivet, and the number of rivets per pitch length in bearing or crushing. Note, bearing pressure is the local compression which exists at the surface of contact between two members of a machine part that are in relative motion. So, pag gumagalaw siya, pressure na yon. Pag steady, that is stress. So, bearing pressure, Yan. So bearing pressure, PB is equal to F over LD, where PB is the average bearing pressure, F radial load on the journal, yung bearing, and length of the journal in contact, the diameter of the journal. Next, torsional stress and angular of twist. Angle of twist. Okay. Torsion is the state of machine member subjected to the action of two equal and opposite couples acting in parallel planes, or torque or twisting moment. Torsional shear stress is the stress set up by the torsion. It is zero at the central axis and maximum at the outer surface. So maximum torsional stress, shear stress is for shaft is tau over r is equal to T over G is equal to G times theta over L, where tau is the torsional shear stress induced at the outer surface of the shaft or the maximum shear stress. Tingnan nyo sa figure. R is the radius of the shaft. T, the torque or twisting moment. J is the second moment of area of the section about its polar axis or polar moment of inertia. G is the modulus of the rigidity for the shaft material. L is the length of shaft, and theta is the angle of twist in radians on a length. Andyan sa figure. So for solid shaft, J is equal to pi over 32 times the exponent 4. And the shear stress is 16T over pi d cube. For a hollow shaft with external diameter DO and internal diameter DI, J is equal to pi over 32 times d sub O exponent 4 minus d sub I exponent 4, and R is equal to DO over 2. So the shear stress tau is 16T DO over pi, O exponent 4 minus DI exponent 4, or tau is equal to 16T over pi DO cube plus 1 minus K exponent 4, and K is equal to DI over DO. Torsional rigidity of the shaft is equal to J times J. Power transmitted by the shaft is P is 2 pi NT over 60 or T times the angular velocity, where T is the torque transmitted, W is or omega is the angular speed in radians per second. Sa English units, P is equal to NT over 63,000 or 63,025 ang exact. So N, RPM, and T is the torque in inch pound. Ang unit na inch pound. Tapos RPM. So example number 36, determine the outside diameter if a hollow shaft whose inside diameter is 1 inch. If it is to replace a 1.5 diameter solid shaft for power transmission, the shaft have equal torsional strength. So tau is equal to 16T over pi d cube sa solid shaft. Sa hollow is 16T DO over pi DO exponent 4 minus DI exponent 4. So therefore, equal ang T niya. So magiging d sub O exponent 4 minus d sub I exponent 4 is equal to d sub O times d cube. Since DI is 1 inch and D is 1.5, so D sub O exponent 4 minus 1 exponent 4 is DO times 1.5 cube. So DO is equal to 1.588 inch. So the correct answer is 1.75 using the next highest side. Hindi ka naman pwedeng kumuha ng 1.5 kasi malapit, di ba? So letter D. Next, a circular bar solid cast iron 60 inches long carries a solid circular head 60 inches diameter. Ay, yung bar carries a solid. The bar is subjected to a torsional moment of 60,000 inch-pound, which is supplied at one end. It is desired to keep the torsional deflection of the circular head below 1 over 32 inch when the bar is transmitting power over its entire length in order to prevent the shattering of the piece. What would be the diameter of the bar? If the working stress is taken as 3,000 psi and the transverse modulus of elasticity is 6 million psi. Okay? Solving for diameter using shear stress formula. Tau is 16T over pi d cube. So 3,000 is 16 times 60,000 over pi d cube. So the diameter is 4.67 inch. Solving for the diameter using torsional deflection, delta is equal to r theta. So 1 over 32 is equal to 60 over 2 times theta. 60 inches. So theta is 0.10004 radian. So theta is equal to TL over JG. 0.00104 is 60,000 times 60 over pi over 32. The exponent 4 times 6 times exponent 6. So diameter is 8.75 inch. Therefore, the surface diameter of the bar is 8.8 inch. Okay. Tindihan nyo na lang yung problem. So determine the polar moment of inertia in millimeters exponent 4 of this shaft 32 mm diameter delivering 10 kilowatt at 200 RPM. So J is equal to pi over pi d exponent 4 over 32 is pi times 32 exponent 4 over 32 is 102,943.7 millimeters exponent 4. Okay? No need na itong 10 kilowatt sa 200 RPM. More next some problem kasi. Okay? Sample 39. Find the torsional stress in megapascal in 40 mm diameter shaft that transmit 20.53 kilowatt at 600 RPM. Okay, the power is 2 pi Tn. Or 20,530 is 2 pi times T times 600 over 60. So T is equal to 326.75 Newton meter. Then the torsional stress is 16T over pi d cube or 16 times 326.75 divided by pi divided by 4.040 cube or 26,000,001 Pascal or 26 megapascal sa letter A. Yeah. Shafts in series in parallel. Composite shaft composed of two shafts of different diameters connected together to form one shaft. Shaft in series where the driving torque is applied at one end and the resisting torque at the other end. So let figure A. Itong kabila. Shaft in parallel where the driving torque is applied at the junction of two shafts and the resisting torque at the other end of the shaft. So they apply. So dito, series kasi magdadagdag yung deflection niya, yung angular twist niya. Magto-total. Sa parallel, so equal yung angle of twist niya dito. So shaft in series, total angle of twist is theta 1 plus theta 2 is T L1 over G1 J1 plus T L2 G2 J2. That is, ang constant mo dito is yung torque. For shaft of the same material, G1 is equal to G2 is equal to G. Shaft in parallel, theta 1 is equal to theta 2. Okay? So, ano mo naman dito, ang torque, hindi siya. That is T1, L1 over J1, J1 is equal to T2, L2 over G2, J2. Or T1 over T2 is equal to L2, L1 times G1 over G2 times J1 over J2. For the same material, G1, G2 is equal to G. So T1 over T2 is equal to L2 over L1 times J1 over J2. Okay? Check. Ayusin natin itong pause muna. So, okay, ito. T1, L1 over J1. Ito na yan. So, T1 plus T2 is equal to T, yung total. Yeah? Next, bending or flexural stress. M, based sa figure, M over I is equal to sigma Y over ER, where M is the bending moment acting at the given section. Sigma is the bending stress. I is the moment of inertia of the cross-section about neutral axis. E is the Young's modulus of material of the beam, and R is the radius of curvature of the beam. So bending moment, sigma is equal to MC over I is equal to M over C, where Z is the I over C is known as section modulus. Example number 40, a horizontal beam 16 feet long is subjected to a load of 500 pounds located to its center. The dimension of the beam is 2 by 4 inches respectively, and its unit weight is 100 pounds per foot. Naka-animation pa. So, from the figure, so 16 feet yung beam is subjected to a load of 500 pounds located to its center. So, tapos meron din namang unit weight na 100 pounds per foot. So, yan magiging ano mo. Then get the reactions. Symmetrical to. So, equal siya. So makuha mo niya is 1050 and 1050. Then draw the shear diagram. So reaction ng 1050 ito. Then gradual yung pagbaba niya up to dyan. Tapos ma-minus yung 500. Then gradual uli, bababa. Tapos this mag-equal to dapat sa 1050. Tapos taas naman sa so 0 na. So ipapat mo to, ang slope nito is sa moment is ang slope niya is increasing, hindi decreasing. Okay? So kaya gagawa ka ng curve na decreasing ang slope hanggang sa mag-0 sa taas. So actually tama, 0 din dito, 0. Yan. Tapos ito naman ganun din. Yan. Basta ito yung maximum point mo, 0 dyan sa 0. So R1, R2, ito nga 105. So then moment now is yung product lang ito. Yung area nitong A1. So A1 is equal to A2. Okay, yung makukuha mo yung value ng maximum niyan. So 1/2 of 800 times 8. Asan yun? Plus 250 times 8. So this is 800. So 1/2 of ito. So kung ano mo siya, ito is 250. Kalahati yan, di ba? 250. So wala naman kayo ng ano share and moment. So na 250 to. So this rest sa taas is 1050 minus 250 is 800. So kaya yung 800 triangle siya, 1/2 of 800 times 8. Yan. Plus 250, itong taas na 250 times 8. So this is 52 foot-pounds or 62,400 inch pound. Eh? Ayan, pa pala. So SF, so is sigma F, okay yan. MC over I, C is equal to S over 2 or 4 over 2 is 2 inches. I is equal to BH cube over 12, rectangle. So 2 times 4 cube over 12 is 10.67 inch 1/4. So the flexure stress 62,000 times 2 over 10.67 MCI to is 11,696.34 pounds per square inch. Letter A. Next, thermal stress and thermal expansion, contraction. Thermal stress is induced in the body if the body is prevented to expand or contract freely with the rise or fall of the temperature. So thermal expansion, contraction is delta L is equal to alpha times L times delta T. Thermal strain is TH is equal to delta L over L is alpha delta T. So thermal stress is equal to sigma TH is ETS times E or alpha A EA delta T, where L is the original length of the body, delta T, rise or fall of the temperature, alpha is coefficient of thermal expansion. Okay? Expansion, pag sinabi expansion, this is positive. Pag contraction, this is negative or yung ano niya, yung actual niya is yung nga, contraction, yung isa lumahaba. So compute sample number 41. Compute the induced compressive stress in kilopascal of a steel solid shafting of 50 mm diameter and 800 mm in length that is subjected to an increase of temperature by ATC. So sigma is alpha A delta T. So alpha is 6.6 times 10 is -6 Fahrenheit for steel. So wala dyan. Oh. So click niyan. So para makuha mo yung malapit na sagot. Yan. E is equal to 30 times 10 exponent 6 PSI. Wala rin dyan. So delta T is equal to 80 times 9 over 5 is 144 Fahrenheit. Since ang value natin is PSI, di ba? Ito yung convert yung ATC, 9 times 9 over 5 lang. Is equal to 144. Wag mo nang dagdagan ng 32 kasi nga increase in temperature yan. So sigma is equal to 6.6 times 10 exponent -6 times 30 times 10 exponent 6 is times 144 is 28,512 PSI. Therefore, convert mo yung 20,502 is magiging 196,529 kilopascal. Kita nyo naman yung 101.35 over 14.7. So example number 42. A steel train rails is 400 meters long. In March, it is negative 30 C and 40 C in July. What is the change in length in millimeter? Cape of steel is 11.7 times 10, point negative 6 meter per meter C. So solution, delta is alpha L delta T. This is 11.7 times 10 is point negative 6. 400 times 40 minus negative 30 is 0.3276 mm. Oops, this is meters. It's now 27.6 mm. So, ayan. 127.6 mm. So, letter C. Next, linear and lateral strain, Poisson's ratio. So, linear strain is a strain in the direct stress on direction. Lateral strain is a strain at right angle of the stress of the direct stress direction. Sa figure naman, di ba? So, pag in-stretch mo siya, so diameter, liliit. Pag kinumpress mo siya, so, yan. Ito, L plus delta L. So, diameter, mag-reduce siya. Sabihin niya. So, the ratio is the lateral strain divided by the linear strain. So, values of Poisson's ratio range from 0.25 to 0.35 for most material. Impact stress. So, mag-ingat kayo dito. Impact stress is the stress produced in the member due to the pulling load. Energy gained by the system is the potential energy lost by this weight. So 1/2 of P times delta L is equal to W times S plus delta M. Then sigma I, the impact stress is W over A times 1 plus the square root of 1 plus 2HA E over WL. For sudden load, so S is equal to 0. So therefore, sigma I is equal to 2W over A or twice the normal stress. So example number 43. A body weighing 1,000 pound pole 6 inches and strikes at 2,000 pounds per inch spring. What is the deformation of the spring? Okay. Solution. So W times S plus delta is the potential energy. Equal din sa potential nito. 1/2 of K times delta S. So 1,000 times 6 plus delta is equal to 1/2 of 2,000 times delta S. So factor out. Delta minus 3 plus delta plus 2 is equal to 0. So delta is equal to 3 inches. Okay. Huwag tong 2. So stiffness and total strain energy. Stiffness is the amount of force required to cause a unit of deformation and is often referred to as spring constant. Total strain energy is the energy stored in a loaded member is equal to the work required to deform the member. So U is equal to 1/2 of F delta or F squared L over 2AE. Combined stresses, so equivalent torque is T is equal to the square root of T squared plus M squared. Equivalent moment, M is equal to 1/2 of M plus the square root of T squared plus M squared. So mechanical engineering, so babalikan natin to pag sa machine design. Review. So combined axial and bending stress, sigma is equal to F over A plus or minus MC over I. Maximum shear induced by combined axial or bending and shear stress is 1/2 of the square root of sigma T squared plus 4 tau squared. Maximum normal stress induced by combining axial or bending and shear stresses is 1/2 of sigma T plus 1/2 of the square root of sigma T squared plus 4 tau squared. Theories of failure under static load. So yun tayong maximum principal or normal stress theory, also known as Rankine's theory. Kasi most of the strength of material book meron to. So according to this theory, the failure or yielding occurs at a point in member when the maximum principal or normal stress in biaxial stress system reaches the maximum the limiting strength of the material in a simple tension test. So sigma maximum is sigma T1 is equal to 1 half of sigma T plus 1 half of the square root of sigma T squared plus 4 times tau squared. So sigma maximum is sigma Y over N for ductile material. Sigma maximum is the sigma U over N for bitter material, where sigma Y yield stress, sigma U ultimate stress, in N is the factor of safety. So maximum shear stress theory, also known as guest or Tresca's theory. According to this theory, the failure or yielding occur at a point in a member when the maximum shear stress in a biaxial stress system reaches a value equal to the shear stress at the yield point in a simple tension test. So say tau maximum is 1 half of the square root of tau sigma T squared plus 4 times tau squared. So tau maximum is equal to tau Y over N. Tau maximum is the maximum shear in a biaxial stress system. Tau Y is equal to shear stress at yield point. N is the factor of safety. Biaxial, so X and Y axis lang. Or tau maximum is sigma Y over 2N. Then the maximum principal or normal strain theory, also known as St. Bernard theory. According to this theory, the failure or yielding occur at a point in a member when the maximum principal or normal strain in a biaxial stress system reaches the limiting value of strain, that is, strain at yield point, as determined from simple tension test. So sigma T1 minus sigma T2 mu sigma T2 is sigma Y over N. So sigma T1 is equal to 1 half of sigma T plus 1 half of sigma T squared plus 4 tau squared square root. Then sigma T2 is yung positive. Gawin mo lang minus. Next, maximum strain energy theory, also known as Hayes theory. According to this theory, the failure or yielding occurs at a point in a member when the strain energy per unit volume in a biaxial stress system reaches the limiting strain energy. That is strain energy at yield point or per unit volume as determined from simple tension test. Sigma T1 squared plus sigma T2 squared minus 2 mu times sigma T1 times sigma T2 is equal to sigma Y over N squared. Next is the maximum distortion energy theory, also known as Hinke and von Mises theory. According to this theory, the failure or yielding occurs at a point in a member when the distortion strain energy, also called shear strain energy per unit volume in a biaxial stress system, reaches the limiting distortion energy. That is distortion energy at yield point per unit volume as determined from a simple tension test. So sigma T1 squared plus sigma T2 squared minus sigma T1 times sigma T2 is equal to sigma YT over N squared. So the maximum distortion energy is the difference between the total strain energy and the strain energy due to uniform stress. Okay? So wala tayong more circle dito. More circle andun sa combined stress. So example number 44. 5.1 centimeter solid shaft has a maximum bending moment of 677.9 Newton meter and an applied torque of 399 Newton meter. What is the equivalent bending stress and megapascals? So ME is equal to 1 half the square root of M plus the square root of T squared plus M squared. Is equal to 1 half of 677.9 plus the square root of 339 squared plus 677.9 squared is 717.918 Newton meter. Sigma is equal to 32 ME over pi D cube is 32 times 717 0.918 divided by pi over 51 cube is 55.127. So letter B. Point yan. So the maximum shear stress, pump number 45 induced on 1.5 inch diameter solid shaft loaded with a torque of 3,000 inch-pound and a bending moment of 12,000 inch-pound is shear stress at TE is equal to the square root of T squared plus M squared. The square root of 8,000 squared plus 12,000 is equal to 14,422.2. So tau is equal to 16 TE over pi D cube is equal to 16 times 14,422.2 over pi 1.5 cube is 21,760 PSI. Letter A. Okay. So variable stress. So meron pa rin to sa strength. Pwede lang siguro na di-discuss kasi sinusulkat na pinupunta na sa mga shear and moment. Okay? Shear and moment, simple lang naman ang review natin. Soderberg criterion, ductile, 1 over n is equal to sigma m over sigma y plus kf, sigma b over sigma e. So Goodman's criterion, 1 over n is equal to sigma m over sigma u plus kf, sigma b over sigma e. So mga symbols, alam nyo na. So then sigma m is the mean or average of maximum and minimum divided by 2. So sigma b is yung variable alternating is sigma maximum minus sigma minimum over 2. So example number 46. The shaft whose torque varies from 2,000 to 6,000 inch-pound has 1.5 inch in diameter and 60,000 PSI yield strength. Compute the shaft mean average stress. So akala nyo, pag lumabas to sa board na board problem yata, board problem din to. Ayan, simple lang. So tau max is 16, T max over 5D cube is 16 times 6,000 over 5 over 1.5 cube is 9054. Minimum is 3,018 sa 2,000. So average mo, 9054 plus 3018 over 2 is 6,036 PSI. Okay? So now, continue na lang nyo yung review. Okay? Hanggang dito na lang to. Thank you very much.